So thank you, Manfred, and also I want also to congratulate the organizer, especially Carmen and José Kenny, about this conference, because they are well done the organization of this conference, and as a lot of people join, it seems that that's a big success, and we expect that to have the same, even more, in the next 2 years. So this, for this lecture, I will give a few insights about what we are doing, and taking a specific case about how we can nanostructure some polymers, thermoplastic polymers, with inorganic rich phase at the nanoscale. So using different routes, and especially the salt gel process. I would not take time so much about the about the properties of those materials, but having more focus on the morphologies we can create from that kind of approach. So this work was done in collaboration with Philippe Cassagnon, who is here, but also Arnaud Prévé, who was one of our common PhD students. So very general feature about nanostructured polymers, you know that of course most of you are familiar with nanostructured polymers due to the fact that we expect from nanoscale some interesting new properties, especially physical properties as barrier properties, mechanical, and etc., or combination of properties. And one thing which is of interest is also that in such materials we develop a large amount of interfaces in between the different phases, whatever the system used for nanostructuration. The second point is very general about nanosize in organic rich phase. Inorganic in polymers, as we are polymer scientists, is interesting because we can expect that the combination of the inorganic phase, having its own properties, could be combined in interesting way with the organic component as polymers, in order to combine stiffness, for example, and softness, and any kind of other properties. And also with inorganic nanophase structure, we have also a lot of available morphologies and size and shape factor with nanoparticles, nanorods, etc., which can introduce themselves specific properties. So there are different ways to nanostructure polymers with an inorganic rich phase. Is to first to add, for example, as I will show you, already preformed nanofillers as silica, in that case, pure silica. It could be clay, it could be any kind of other inorganic nanoparticles. It could be also to generate in situ to overcome some processing problems. I will be back in that feature also, from salt gel chemistries, including some new type of salt gel chemistry which are developed in the inorganic science side. And the third way I will not develop here, and that was shown by Saverio Rousseau this morning, is to use, for example, meta-oxoclusters as POS, for example, which are well-defined molecules which can be put into the polymer and to be assembled into larger inorganic rich structure. So if we look to the nanoparticles already preformed and put into a polymer, the problem is processing. So processing, because why? Because if you put some particles into nanoparticles into a polymer, you will reach a very difficult problem of coming from the interaction between those colloidal particles, and the consequence will be a high viscosity of the system. So most of the time it will be difficult after that to process the system. But interesting feature is also that you are strongly dependent on tool and how you will work with dispersion. But the interesting thing is that you can do some already done and well-known chemistry from the surface, and from the grafting onto, and all of the technique for modifying the nanoparticles. So the morphologies, the restricting morphologies is strongly depend, of course, is related to the state of dispersion, which is a key parameters for the properties. And you know that if you well disperse or non-well disperse, assemble, aggregate, and etc., you will get final physical properties which will be different. Interesting thing is that point, which is the large range of variable geometries, I mean shape factor, which will not be so easy done using, for example, soil gel system. In soil gel chemistry, you could overcome completely the problem of processing because you go from a very small, low molar mass component, which is, for example, a metal oxo system with a low molar mass or low viscosity, but the problem is that you will need to do some chemistry now, and to take care especially about the miscibility with the medium in which you will put the system, because you will play with what we call a reaction-induced phase separation, because you will begin from a miscible system at the beginning and precipitate at the nanoscale from inorganic rich phase into the system. So low viscosity, nice for processing, and you can also overcoming the problem of processing, but the problem is to have also good interaction in between the polymer organic medium and the inorganic phase, which could be overcome and solved using what we call coupling agents, so system in which one part will be attached and grafted onto the onto the inorganic phase, and the other part will interact or react with the polymer. So interface are solved, low viscosity and processing are solved. And if we take care about the chemistry of the system, we can design nice morphologies. And there are some papers, even in that area, in that conference, which will describe also how to use the inorganic soil gel chemistry to, for example, to be done in already ordered organic medium as block copolymers. So I will show you how we will play, and I will take one example, which is a PLA, a well-known and fashion type polymer at the moment, and with its monomer. And we will play with silicon-based inorganic phase, which could be fumed silica already preformed or generated in situ from alkoxysilane system. So the polymer matrix will be done from the polylactic acid alone, already preformed, or using directly the L-lactide, and the silicon-rich phase will be fumed silica, preformed particle, or silicon-rich particle. I can say silica because that's not always a perfect SiO2 phase, done from silicon precursors, and we will combine